Hello Year 10. In this video we're going to look at simple interest, compound interest and depreciation. So simple interest first of all is when you put money in a bank, they'll pay you interest. So they pay you a bit extra on your investment. If you borrow money, you pay them interest. So you have to pay a bit extra back. And simple interest is worked out on a yearly basis. So they work out a rate per year. And we'll often see this phrase per annum, which is Latin, which means per year. Okay, so Sally put £600 into an account with a simple interest rate of 5% per year. Calculate the interest Sally receives in 1 year and find out how much money she has in her account at the end of 1 year. So we're finding 5% of 600. We're adding on 5% to the original amount, which we think of as 100%. So her new amount is 105%. So 5% of 600, if we divide by 10 and half it, we get £30. So we add on £30 to the amount she's got. So with simple interest, every year we would add on £30. The amount stays the same every year. So we're going to look at a faster way of increasing by percentages. Okay, so if you're increasing by 5%, you add it to 100%, which is 105%, and then you can divide by 100 to turn it into a decimal, because percentages turn into decimals by dividing by 100, and it gives you 1.05. So what you can do is just multiply the amount of money, or the amount that you're trying to increase, by this multiplier 1.05. Okay, so we're just going to look a bit more at that. So if we had an increase of 5%, add it on to 100%, turn it into a decimal, and then we multiply. If we had an increase of 15%, add it on to 100%, turn it into a decimal. 30%, 3%, notice the difference between those last two, very often confused. 17%, 0.5%, another one we need to be careful with. Okay, so increasing by a percentage, add it on to 100%, divide it by 100 to turn it into a decimal, and then multiply by the amount of money or whatever it is that you're increasing. So another example, Joe invests £4,000 in Rip-Off Bank at a simple interest rate of 3% per year. How much will he have after 1 year? So we've added 3% onto 100, divided by 100 to turn it into a decimal, and we multiply by 4,000. So 4,000 multiplied by 1.03 gives us the amount that he'll have at the end of the year. So we can see that it's gone up by from 4,000 to 4,120. It's gone up by £120. So the amount that's increasing is £120 per year. And with simple interest, it would be £120 every year. So it would stay the same. Okay. So year 2, you'd add on another 120, and then year 3, you'd add 120 onto that, and so on. Okay, so another example, if she invests or he invests £250 in Superbank at a simple interest rate of 8.5% per year, add that on to 100%. Really common mistake people make is to think that this is 1.85, that the multiplier be 1.85. But if we look at it when it's added on to 100%, it's 108.5. Divide by 100, it gives us a multiplier of 1.085. So it's really important to go through this process of adding it to 100% and then dividing by 100 to make sure you get the right amount. Okay, so we're multiplying by 1.085. So that gives us the amount that we've already got plus an 8.5% added on. Okay, so we multiply by £250. And the new amount is £271.25, an increase of £21.25. So after 2 years, we'd add on another £21.25, and so on. Okay, so we're going to look now at depreciation. So depreciation is when the value of something goes down. So for example, a car depreciates in value at a rate of 30%. So you drive a car out of a showroom, before you've even got to the end of the street, the value of that car will have gone down because it's no longer brand new. Okay, and so we're going to, this example, where this car depreciates at a rate of 30%. Initially, it cost £25,000. How much will it be worth after a year? So just in the same way as with increases, you added it onto the percentage, you added it onto 100. With depreciation, you take it away from 100. So you take away 30%, which leaves you with 70%. You turn that into a decimal by dividing by 100, and then you multiply. So the method's the same, except with decrease, or depreciation, you take away the percentage from 100 and turn it into a decimal, and then multiply. Okay, so let's look at some examples. If you're going to decrease by 5%, take it away from 100%, divide by 100 to turn it into a decimal, and multiply. Same with 15%, take it away, turn it into a decimal, and multiply. Okay, so the method is the same, except you're taking it away from 100%, divide by 100 to turn it into a decimal, and then multiply by the amount you want to decrease. So let's look at an example. A company's shares depreciate at a rate of 11%. Initially, one share is worth £32. How much will it be worth after a year? So it's going down by 11%. Take that away from 100% is 89%. Turn it into a decimal, and then multiply by £32. Okay, last thing we're going to look at is compound interest. So this is different from simple interest because the amount of interest increases every year. So with simple interest, you find the amount of interest at the beginning of the year, or in the first year, in the first investment, and you add on the same amount every year. Compound interest, you find a percentage of the new amount every year, so it continually changes. So it's probably sounding a little bit difficult to get your head around at the moment, so let's just look at an example. So we've got £600 and it's increased by 3% per year compound interest. So the first year, we do everything the same as we did before, add on 3%, turn it into a decimal, and we get our multiplier of 1.03. So the first year is the same, £600 multiplied by 1.03 gives us £618 at the end of year one. Okay. However, whereas with simple interest, you would have just added on the extra £18 every year, with compound interest, you find 3% of the new amount and add it on. So the following year, you will multiply £618 by 1.03 to get the new amount. And then in year 3, you multiply the amount you had at the end of year 2 by 1.03. And then at year 4, you multiply the amount you had at the end of year 3 by 1.03, and so on and so on and so on. Okay, so you're always multiplying the new amount by the multiplier, by the increase, to work out the following year. Okay, so you can see that the amount of interest increases every year. It gets a little bit bigger because you're finding 3% of a larger amount every year. Okay. So the trouble with this method that I'm showing you here is it's quite time consuming. If you were trying to find how much money you had at the end of 10 years, for example, that would take ages. You'd have to go through all of that. So I'm going to show you a faster way to do this. Because what we're essentially doing here is we're multiplying by 1.03 repeatedly. Like 1.03 times 1.03 times 1.03 for 3 years. So that we can use powers to do that in a quicker way, because 1.03 times 1.03 is 1.03 squared. 1.03 times 1.03 times 1.03 is 1.03 cubed, and so on. Okay, so first year is the same, 600 times 1.03, but the second year, we can start with the 600 and just multiply by 1.03 squared, because the power of 2 is the number of years the investment is being put in for. Okay. The third year be 600 times 1.03 to the power of 3. Fourth year, 600 times 1.03 to the power of 4, and so on. So if you were trying to find 10 years, you'd do £600 multiplied by 1.03 to the power of 10. And you can do that in one go. So it's a lot faster than doing it 1 year at a time. Okay, you just simply put a power of the number of years, or the number of times the interest is being applied, next to the multiplier. Okay, so let's just recap that. To calculate compound interest, the power is the number of times it's applied, usually yearly, nearly always per year. Okay, occasionally it could be per month. So that's why I haven't written per year, but it's the number of times you're applying that compound interest. So you do need a scientific calculator to do this. If you have one to hand, if you have a look, you'll find that, sorry, it's just jumped. You'll find that there is a button on there next to the x squared button or x cubed button with x to the power of, and it'll either be n or a little empty square. Okay, and you can use that button. So if you wanted, say for example, 1.03 to the power of 4, you'd put 1.03, press your little xn button, and it would give you the option to then put in that power of 4, okay, or whatever power you want. If you haven't got a scientific calculator, you can Google one and get one up on your screen online, and maybe look at trying to have one for coming back to school in September. So last example then, £100 to increase by 12% per year compound interest. So the first year, we're going to multiply by 1.12. That's our multiplier. Year 2, we'd multiply by 1.12 to the power of 2. If we wanted to know after 3 years, 1.12 to the power of 3. After 4 years, 1.12 to the power of 4. 10 years, 100 times 1.12 to the power of 10. If it's 50 years, 100 times 1.12 to the power of 50, and so on. So rather than having to find a new amount and then multiply by 1.12 again, find a new amount, multiply by 1.12 again, you can just do it in one go by work out the multiplier, and then the power is the number of years that interest is being applied for. Okay. So quick recap of everything we've learnt in this lesson today. Max has 1,000 in the bank. If he gets simple interest of 5% per year, he will multiply by 1.05 because we've added on 5%, and that works out as an extra £50 every year. So the following year he'd add on another £50. And indeed, if he kept his money in there for 3 years, it would earn another £50, and so on. That amount would be the same. If it's compound interest, however, we would multiply by 1.05 to the power of 2, because he's keeping it in there for 2 years. So at the end of 2 years, he'd have £1,102.50. Okay. If his money goes down, I don't think you'd want to have your money in a bank where it went down, but if his money was going down by 5% every year for 2 years, we take 5% away from 100%, 0.95 is the multiplier, because that would be 95%, divide by 100, 0.95, and it's for 2 years, and it's depreciating by 5% every year, so that would be multiplied by 0.95 to the power of 2 for 2 years, which would give him £902.50. Okay, so I realise there's quite a lot to take in this video, and you may have to watch it twice. You may have to go back over it and pause it and perhaps make some notes. As always, if you need some help, please get in touch with your maths teachers. We're always willing and happy to help you, and thank you for watching.